Hello everyone, welcome back to RCH Builders. So today we do not have any video that we are going to be able to do for the house down with our investment home. We have not been able to make it back down there again, and I know that's what's been coming out on Saturdays. But instead, what we are going to try to do, we've got a job where we're going to need to change out a couple receptacles and possibly a switch to like a dimmer switch, some stuff like that. So we'll try and go ahead and get that tutorial on how to change out and replace receptacles and switches, and trying to show y'all how I prefer to do that, and both what may be easy about doing a change out receptacle and what may be difficult depending on the situation. So what we have first is we have an outlet. I'm going to show you where a prong from a cord has been broken off inside the ground. So we're going to go ahead and get to there and take a look at that and see what we got to do to change that one out.
Alright, so this is the receptacle that we're going to change out. You can see where it's been broken right here, part of the device itself. There should not be no crack there. It's hard to see on camera. You can very lightly see the little piece of metal that's stuck inside there. Not sure. Let's see. Oh, there we go. That camera is zoomed in pretty good. So you can see it's broke off inside there. There's no way that you would, even with the power off, be able to pull that out. You can also see it's been worn out right here anyway. So we're just going to change out the entire receptacle. So we've got the power turned off, of course. The cover plate is perfectly fine, so we can save that. And there's problem number one besides just changing out this outlet. So what they have, whoever did this the last time when they put this in, this is a low voltage box. So when I take out this receptacle, you will see that there is no back on this box at all. It's designed for low voltage, which is typically going to be just coax for your internet, maybe your TV, or for telephone. It's all low voltage items that do not need to be in a box. The box is technically, it's just a ring that is there to allow you to have something to mount the device to. It's not needed to protect the wire from being connecting to anything it shouldn't. So we got wire that's just hanging here because there's no box. And you can see straight through to the other sheetrock on the other side. You can see the wood right there, which is flammable if this was to end up connecting. So we'll also have to replace the box. If these wires were in a box, you can see how short they would be. That would be very difficult. The fact that it's not in a box is actually making it easier for me to take this receptacle apart. So hopefully this opening is not too big for a rework box. Typically these rings, like I say, it's just a ring, that's all it is, are a little bit smaller than a rework box, but that doesn't mean they cut it just big enough. Alright, so we got the box apart. I'm going to straighten all these wires because it makes it a lot easier to get them inside the rework box correctly. The straighter they are, the better. And another thing we can do, because these wires are so short, is we can see if there's any way we can form them to make them longer once they're in the box. So we could pull up a little bit from below. That helps. This one was curled in a weird way that gave us a little extra. A lot of times when you're doing this, you cannot stretch the wire when you change out a receptacle. So like I said, in this case, because they used the wrong box, so far to an extent it is somewhat working in our favor, to where we can actually give ourselves something to work with. So I'm basically just using the tip of it to squeeze it straight. You don't want to squeeze them too hard or shear them. And we got our rework box. You can measure these off, but when the hole's here, you can already tell width-wise we're good. Height-wise, you can see these flanges, if you put them in here, they are not going to catch. It's not going to work. So you can't even use these to hold it in, because all it's going to do is pull the box all the way in. It will not be solid. Also, in another video that I did on electrical that was done incorrectly, I showed you that you are not allowed to put a screw inside this box. So we can't fasten it this way, straight back the way it's designed to work. We can't put a screw in the side to hold it. So how are we going to put this box in? So there is a trick. Take out the wings. This works. You can do it in a lot of plaster homes in any location, but you can also do it in most houses, because most times these boxes are going to be right next to a stud, which this is. There's a stud right there. So we're going to remove these screws. You can use these screws to do it, but they are a little bit more difficult to operate. So two further in the bottom, one in the top. Just open it up slightly. Just start them all. And getting them started in there when they're already open can be a little bit of a pain, because it's very easy to end up with a wire coming out like up here where you don't want to. So you gotta work with it a little bit. And then also where it's stripped back, the sheathing doesn't want to go in. But in order for this to meet code and be correct, that sheathing needs to be solid when it enters the box. So you gotta finagle it until it finally cooperates. That's an electrical term. No, I'm just kidding. And then the top one, which is even more difficult. The reason I saved it for last is because it's only one of them. But whichever end you do last is going to be more difficult, because now the end on the opposing side is wide open, being held open more by the previous wires, which
Makes it easier to end up with a wire going where you don't want it to, but at least it's easier the fact that there's only one set versus two. So if I did the top first, I'd be doing the same thing, fighting it, but fighting it with two sets of wires instead of one. There we go. Gonna try and pull as much of that slack that we created up in there as possible to make this a little easier when we're done, when we go to make it up. And there's the box. Like I say, it's just, the opening is too big. It'll fall completely inside the wall, or it'll come out. And you are not allowed to screw it in here. However, this is what you are allowed to do. This up here is not inside the box, it is outside. So, like I said, you can use these screws, the same ones you took out, and at a slight angle, you want to try to angle it just enough to slide back in there and hit that stud. And that's where I was saying, with those screws, they are very difficult to maneuver. It's much easier with just a standard sheetrock screw. Get started, get the box in the right spot. And then again on the bottom, you want to be outside of the box. So no screws, no metal is inside the box. You are allowed to do it outside. So now that the box is in there and it is solid, it will not move. We can go ahead and strip back just a little more of this sheathing to give ourselves a little bit of play. And I have another previous video where I showed how to make up all this. However, I didn't do with a receptacle that has 3 wires in it. So the only thing that's different in here versus that one, I'm going to do the grounds the same exact way with the green wire nuts. So they had 2 wires under 1 screw in the receptacle. You're only supposed to have 1 wire under each screw per manufacturer. So for that, we will have to tie all the whites, all the neutrals together, and all of the hot legs together, and have pigtails for each of those. So the box that I used is the extra deep box, so there's plenty of room for all the wire nuts and the receptacles. In most cases, I'm going to use the deep box no matter what. This just gives you more room to work with. So I'm gonna go grab some wire nuts, some pigtails, and I'll be right back. Alright, so I went ahead and I just made up the ground real quick with that green wire nut that I showed in that previous video, how to prep a switch and receptacle, or maybe it was how to prep a receptacle and switch. I'm not sure in the title, but you should see it. I might put a link up top if you're interested in that. But the difference in this case versus that one is, again, I'm having to do pigtails, which you can just use another short piece of wire, like scrap piece of wire you get laying around. Just pull out what you need. Typically, when I'm on a main job where I'm doing a bunch of electrical, I will have all kinds of little pieces to be able to do this with. So there's no reason to have to go buy a whole spool of just white or just black wire to do it. That's all I'm going to do is just tie them all together,
Typically, I prefer these to be longer, but again, this would be what's considered grandfathered in because this is all we have to work with. I was able to stretch it as much as I could. You want to always make sure that your pigtails match the phasing as far as what it is. You could use a red because it is also considered a hot leg, but I usually will try to, if I do have the same color, I will keep it that way. It just helps make sure that anyone else coming in behind me is not going to be confused as to what was done, because oftentimes in receptacles, if there is a red wire in there, it is commonly used for a switched receptacle versus a receptacle that has power at all times. So it'd be maybe a receptacle you put in for a lamp. That's all that was left off that ground. I'm going to cut these a little bit longer because I generally prefer to leave them still close to 8 inches even outside the box. It's much longer than is required by code. I'm going to strip back roughly about an inch. It's just, you can measure it. You don't have to, but once you've done it a lot, you can you judge just how much. You're going to take it not quite halfway with the stripper and just roll it, and that should create the perfect loop. There are other options. I used to have a electrical Klein Phillips screwdriver that had a pin right here that would let you do that. But usually, just about all wire strippers now come with, they'll just have a nub, and it's on both sides of this one for rolling that wire. So, then we'll grab our new receptacle. This one is tamper resistant. So you'll see this little plastic pieces inside there. That is what that does is, this is supposed to be approved for children. You're supposed to use it in all homes and businesses where children can easily access this receptacle. So if it's in a doctor's office, like in the waiting room, they should all be tamper resistant. What that does is you can sit here and take any flat or little pokey thing, of course, you know, a key or whatever, and you can sit here and you can press on this all day long. It will not open. This one will almost open, but not all the way. This is the neutral side. The wider side is the neutral side of the receptacle. It will almost open, but it will not open all the way. It will only open the rest of the way if this is pushed at the same time. Most kids are never going to figure that out, and they're usually operating with one item. So it's to help at least make it less apt for them to be able to poke in something. You have to apply pressure to both of these at the same time for this to actually open and be able to be electrocuted by it. So it at least makes it harder for them to be electrocuted. So with this, you're going to have your ground screw. I always start with the ground and then the neutral. It's commonly considered that you should do that in case somebody turns on this breaker while you're working on it or whatever. And typically they will tell you do the same thing in reverse if you're taking it apart. Save the ground for last. So I will put the ground on first, then I'll go to the neutral, and this works for multiple other things as well, as far as the fact that by doing the ground and then the neutral, in most houses the receptacles are going to face the other way from this. So by doing them first, and I always tighten down all screws, including the ones that do not have a wire. It just helps keep it from being loose or sticking out extra where another wire could possibly hit it. So now that the ground and the neutral is made up, you can flip it and hook up the hot leg. So this little nub right here on the side of the receptacle, if you have tweaked these, measured it exactly right, you should be able to just pull up. And see how that closed that? The other trick is I always roll upward. When I did this, you notice I rolled it upward to create that loop. And when this is facing this way,
And also that's another reason for having it this way. When you put that on there with it facing upward and then tweak it, when you tighten this screw down, we'll do it over here. When you tighten this screw down, it is going to turn the same direction as that loop. And that is actually on purpose. What that does is that when you tighten the screw down, it will turn it. I don't know if you can see it, but that wire turned ever so slightly and tighten. If you have that loop going the other direction, the opposite direction that you are turning the screw, it will open up and loosen. So that's another reason that I do it the way I do. It just helps tighten everything up and keep it tight. So some people will use electrical tape on the sides of these. It is not needed. It's not required. I do it when it is a metal box because the room is a lot smaller and there's actually something for these screws to hit up against. But if you do not fold these wires correctly when you're putting the device in, it doesn't matter if you have electrical tape on there or not, because these wires should be folded in such a way to where they cannot fold back on it. If it folds back on it, it's going to go in between the electrical tape and this. So as far as that goes, the electrical tape is not really going to help, other than if this receptacle is in here and this is a metal box and someone plugs something in and wiggles it, it could, especially with a metal box, there's enough play in this little oval right here for this to hit the side of the box. So that's why in a metal box I will do it. In a plastic box I usually do not. So another trick, because of the fact that this opening is too big, and with that and the way we had to fasten to the screws, this box is sitting crooked and is not able to sit flush. So if I tighten this receptacle down all the way, it's going to make this receptacle sit crooked. The other thing that it's going to do is it is going to either pull it too far in because of the way it's crooked there to where it won't sit flush with the cover plate, or if I leave it out enough, when every time you plug something into it, it's going to go in and out. So the receptacle is going to move. So I have a trick that I've been doing. You can use little washers, but that's just another thing you got to carry. If you're an electrician, you're going to have something that's much simpler with you. Or if you're doing electrical, you're probably going to have it. All right, so what I do, you already have this extra wire here, or I actually do carry a lot of times just one roll of wire. Number 12 works, 14 works just fine. Basically, all I'm going to do is I'm going to use a regular Phillips screwdriver, that is just nice and straight, and I'm going to hand make some springs. This is what I have done many times. It works great. It's something you're already going to have with you. You're just going to twist it around, hold it there with a pair of lineman's pliers. It's just creating a little hold point to keep the whole thing. You can tighten it kind of tight. You don't want your spring to be super tight. You're wrapping it as tight around here as you can, but of course you want the gaps. You're making a spring. And whenever you get to the other end, you should be able to let go of this. It should be pretty tight, and just use the linemen's to tighten the other side. And now you can just slide it off. And usually if I make something like this, this is either 2, 3, or possibly even 4 springs, depending on how much I need. Here I don't need a lot. The bottom came out pretty flush. I will probably be fine down here. The top is where I need a little bit, and I don't need much. I will probably only take about 3 rolls. So I'll just take a pair of wire strippers, clip that, and I dropped it. I will slide it on to the wire because I'm just using it as a spring. Get it started, and then get the bottom one started.
I missed. Can't see.
There we go. So a receptacle, when it is put in, should be kind of tight, but you don't want it super, super tight. It should be just tight enough that you can't just easily wiggle it. And I will usually leave it just a hair loose to where I can forcibly, if I want to, tweak it left and right so that it'll be level. It just makes it look better when it's done. Another little thing that usually I can either do it or the homeowner can do it themselves if they want, is simply take the screw off. Take the cover off here and put just a little bit of caulking back there to seal that gap. So it's just from where it was too big. You could actually, at the beginning of the video, you probably noticed that you could see that ever so slightly. So it was there to begin with. It's just from where they made the hole way too big. So there it is, changed. You notice I usually will always put my screws straight up and down. It looks really good on a switch box, and then I just do all the other ones to match. All right, everyone. So that took a lot longer than it was supposed to. We found a whole lot more problems than they were supposed to. It was supposed to be just a simple change out of receptacle type thing. But as you saw, we found multiple issues that we had to fix as well. So that will probably be it for this video, and we'll try to do a switch change out or on another one. But hope you enjoyed watching, and we'll see you the next time.